Well, welcome to class. Today we're going to start you on your journey of learning how to program in Python. Today's lesson is fairly straightforward. You've probably seen some of this in middle school and high school algebra. I'm going to tell you about how numbers are represented in Python, and then we'll discuss how to build arithmetic expressions by combining these numbers. I don't think it's anything that's too mysterious here. Kind of the way you should think about today's lecture is that Python at its core is really just an overgrown calculator. We're going to give it some data, in this case numbers, and we're going to ask it to do some operations, and it's going to, when it's finished, give us an answer. And so that'll kind of consume most of today's lecture. And then I'll go on and we'll talk about ways to build variables and functions and things like that later on. Okay, let's go to class. Before we jump into the details of our lecture on arithmetic expressions, let me show you about how we're going to handle examples that we're going to consider during lecture. So here I have a Code Sculptor window sitting, and it's got the example we're going to consider here. This is actually the completed example. I'm going to walk through it and fill in all the Python expressions dynamically so you can see how I do it. But the critical thing is we're going to make that file available to you. It's going to, in the break between this segment of the video and the next, we're going to pop up a URL that you can click on, and it will take you to this file inside Code Sculptor. And you can kind of see up here, there's actually a naming convention we have. It's always codesculptor.org. We put a hash mark with examples, and then afterwards we'll have the lecture name.py. And you don't have to remember that. The link will be here. You click on it to pull it up, and you can play around with it either during the video or after the video is over. All right, let's talk about numbers and arithmetic expressions. So to begin, let's just dive right in and have Python print out some numbers. So let's print 3 and -1 and 3.14159 and maybe -2.8. So if I hit run here, sure enough, out come those numbers. Now the thing to note is that in Python there are actually two types of numbers. They're kind of signed whole numbers, things like 3 and -1. And then there are decimal numbers that are kind of have fractional parts and always have a kind of a decimal point here. And in Python, those signed whole numbers are called ints for integers, and kind of the decimal numbers are called floats for floating point numbers. And if you're ever in any doubt about kind of what kind of number you're working with, there's a function in Python that can actually tell you kind of what type of number you're working with. It's called type. So I could say type 3, or maybe type 3.14159. If I run that, well, I'm going to guess this is an int and this is a float. Let's run it. Sure enough, it's an int. This is a float. Now here's a little trickier test. What happens if we ask for the type of 3.0? Now if you look at it, really, there's kind of, this is really a whole number, but somehow it's kind of got this zero fractional part. So in Python, this is going to be a float. In fact, the way we're going to know we're working with the float is we always have a decimal point here, .0. Now there's some functions that we can use to move back and forth between ints and floats, and they're not too complicated. In fact, they're just the function int and float. So I could convert something that is a floating point number into an integer in the following manner. And so these are going to return back some integers. And kind of what integer are we always going to get? Well, the rule is we're always going to get the whole part of this decimal number here. So we're just going to throw away the part to the right of the decimal point. We can also go through and convert an integer into a float. That again seems kind of crazy because, well, an integer kind of is a decimal number. But what you're going to see is the way Python represents this is we're always going to simply put .0 here. Okay, so when you see 3.0, that's really telling you this is a float. -1.0, that's a float. Now before we move on to talk about arithmetic operations, let me give you a few words of wisdom about dealing with floating point numbers. Floating point numbers are only an approximation to a decimal number. For example, when you do 1 divided by 3, you expect a decimal representation of something like 0.333333333 with 3 repeats forever. Computers are not really great at representing that kind of information. In fact, A number like pi doesn't even have kind of even a nice repeating representation. There's a famous episode of Star Trek where Mr. Spock calms a rebellious computer by asking the computer to compute the value of pi to the last decimal digit. And the computer whirs off and goes into an infinite loop, desperately trying to compute the last digit of pi. Now, people who built the computer taken this class, they'd know just have a timeout error there. But the critical question is kind of what goes on inside Python whenever you give it a number that has lots of digits. What does Python do? So let me show you kind of two examples real quick here to help you understand. So what I've done is I've actually grabbed two really good approximations for pi in the square root of 2. So here I have, this is kind of a 50-digit approximation of pi. And then I've also gone and I've grabbed a 50-digit approximation to the square root of 2. So I'm going to actually ask Python now to print these out. And when you do that, notice that I lost a lot of digits here. All these digits here kind of got trimmed down. All these digits here got trimmed down. So what happens inside Python is they represent floating point numbers with about 15 decimal digits of accuracy. So anything beyond that gets thrown away. So in particular, occasionally when you're doing arithmetic operations using floating point numbers, you're going to get answers of the form 4 point and a bunch of zeros and then maybe a 3 at the end. What you're seeing here is something called floating point error. Whereas Python is doing the computation, it can't do the exact precise operation that you're specifying. It can't compute pi to the last decimal point or 1/3 to the last decimal point. So it has to do some approximation. So you're seeing that approximation error there inside that computation. All right, we've talked about numbers in Python. Let's talk about the arithmetic operators that you have available to do computations in Python. Here's a list of kind of some of the basic arithmetic operators. We have plus, minus, times, division, power. It's fairly straightforward. We just take two numbers and apply the operator to them. So we can say something like 1 plus 2 or 3 minus 4 or 5 times 6 or 2 to the 5th power. And if we run that, out comes 3 minus 1, 30, and 2 to the 5th is 32. One operator that you should pay attention to in Python is division. So the way the division operator works in Python 2 is different than the way it works in Python 3. In Python 2, if one of the operators is a floating point number, then the result of division is also a floating point number, and it approximates the actual division. So for example, I could say print 1.0 divided by 3, or 5.0 divided by 2.0, or minus 7 divided by 3.0. And what would come out when I run that is what I'd expect, kind of a decimal approximation of 1/3, 5 halves, and kind of minus 7/3. Notice if both the operators are actually integers, well, Python returns kind of the integer version of the answer. In that particular case, it's the kind of the next lowest integer after you do the exact division. So for example, if I say print 1 divided by 3, or 5 divided by 2, or minus 7 divided by 3. You run that, the answer comes out to be, well, 1 integer divided by 3 is 0. We kind of round it down. 2.5, well, let's see, 5 divided by 2. Integer answer would be 2 here. We kind of rounded 2.5 down. We do minus 7 divided by 3. Well, the integer division is actually minus 1/3. We'll actually talk about division more later on when we talk about remainders, and we'll have a second operator called / is explicitly integer division. All right, we know about numbers, we know about arithmetic operators. Now we're ready to build arithmetic expressions. So the idea is fairly simple. An arithmetic expression is either a number or it's an arithmetic operator applied to 2 arithmetic expressions. This is kind of our first example of kind of a recursive definition. So for example, 2, it's an arithmetic expression. 2 plus 3, it's an arithmetic expression because we've applied the plus operator to 2 arithmetic expressions, 2 and 3. Now in practice, you don't really need to understand that definition. You can just simply go through and type in expressions that you're used to using from, say, middle school algebra. So I could say 1 plus 2 times 3, or 4.0 minus 5.0 divided by 6.0, or 7 times 8 plus 9 times 10. And if I hit run, what comes out is exactly what I'd expect. Now, you might kind of say, well, how did I go from this definition kind of involving an arithmetic expression is an arithmetic expression combined with operators to this thing that I just typed in that's just kind of this flat expression? I mean, I typed in 1 plus 2 times 3. So somehow Python knew that this was really 1 plus then 2 times 3. It turns out there's this notion of precedence, and you probably studied this in middle school algebra. And in fact, you probably have a mnemonic you learned at one point, maybe remember, which was, please excuse my dear Aunt Sally. So the first letter of that phrase, of each word in that phrase, gives us the order in which we should do operations when we're taking kind of this linear version of an expression, trying to think about it in terms of this kind of recursive definition. So it says that when we're evaluating expressions, we should always do parentheses first. And then after that, we should always do exponentiation next. Then we should go through and do multiplication and division, M and D. And in fact, those have equal precedence. So if we have a sequence of those, we just do them from left to right. And then finally, we do addition and subtraction last. So for example, let's type in an expression here, say print 1 times 2, 1 times 2 plus 3 times 4. And if you look at that, the rules of precedence say that we should do multiplication before addition. So this is really the same thing as 2 plus 12. So if I run that, sure enough, I get 14 back from both of them. And notice here's kind of the real rule, which is if you're in doubt about the order in which operations take place, you can always just go through and use parentheses. So for example, if I wanted to do that 2 plus 3 first, I could say 1 plus 1 times 2 plus 3 times 4. And that should be the same thing as 1 times 5 times 4. And sure enough, these both evaluate to 20. So in practice, working with arithmetic expressions inside Python is very intuitive. It's really what you learned in middle school algebra. So I don't think you'll find anything real too tricky here. So go ahead and take a shot at it.